Good morning, sorry. Good afternoon, students. My voice is audible. Can you please confirm? And can you see me? Can you see my screen, Nagaprasad?
Yes.
Yeah.
Sir.
Okay, fine. Thank you. Okay, fine, students. So let me start my discussion. Okay. Meanwhile, let me wait for other students also. Meanwhile, let me open the browser. Okay, online C++ compiler. Yeah. Fine. Okay. Yeah, fine. Okay, students. So let me start my discussion. Yeah. Fine. Since last class, we have discussed about the zero argument constructor and we have discussed about this parameterized constructor, right? So in today's class, we are going to discuss about this explicit constructors and this copy constructor also. These are two topics which are going to discuss in today's class. So let us try to focus on this. Let me clear my drawings. So let me write a small program. Let me define a constructor inside the class. Okay? Inside the class, so let me declare a constructor, and the constructor which I've declared, let me define it outside of the class. Okay. Fine, right? Let me write a equal to x. Right, int x, then a small one called int a1. Okay. Here, no, I can pass step, right? I believe you know about this program, right? So let me do it again. So now what I've done here, students, I've created an object called A1. I've created an object called students, and sorry for disturbance, and internet connection is going up and down. Okay, fine. I hope, can you see my screen, students, now? Can you hear my voice? Can you see my screen, students? Can you respond?
Yes, sir. Yes, sir.
Yeah, thank you. Fine. Okay, fine, students. Yeah. Now, and let us discuss. Okay, fine. So let me write about a small program. Yeah. Yeah. So here, what I've done, students, I've created an object called A1. I've created an object called A1, right? Now, inside this object, I'll be having a data member called A. Okay. Now, as you see that at the time of creating an object, I passed an integer value called 10. So what it means that inside my class called A, I need to find a constructor which is taking a one argument and it should be of type integer. Yes, you can find, students, inside the class called A, I can find a constructor which is taking a one argument of type integer. And here I have declared it, and anything which has been declared, I need to define it outside of the class. So I have defined it. So now what's going to happen? So 10 I'll be passing to x. And what's the value of x? The value of x is 10. And 10 I'll be storing in A. And the value of A will be 10. Right? This is fine. I think you know this, right? And let me clear my drawings. Now, listen very carefully. Now, the same statement I can write like this. The same statement I can write like this. A1 equal to, okay, the same statement I can write like this also. Both are correct, both are valid. Okay, these both are valid statement, right? So let me verify this with respect to, let me verify this by executing this program in online C++ compiler, right? So now let me copy this code. me copy this code and let me run this program in online compiler, right? So this is my online compiler. Let me copy the code, right? So let me remove this, and then statement here. Let me remove this main method, okay? And I need to print the value, right? So in order to print the value, and let me share this only. Now, in this program, now I want to print the value of A, right? In order to print the value of A, let me write a method called void get value, okay? And this method, let me try to define it now. Try to define here after constructor. That's a good practice, students. Generally, when you define, first you should define constructor, but it doesn't matter, okay? It's a best practice, okay? Now, and A. So I'm trying to return A. It should be of type int, and this method belongs to class called A, right? A. And here also I should change the return type to int. Is it right, students? Yeah. And finally, let me print the value. It is cout a1 dot get value, right? So now let me copy this new code. Yes. Let me share the. Yeah. Let me change the code. Same code, and let me copy the code inside my main method. Is it fine, students? Yeah. So that's what I've done, right? Uh, so when I write a1 dot get value, what's going to happen? I'm going to get the value of A. And what's the value of A I'm trying to set? Using constructor. Using constructor, I'm trying to set the value of A to 10, right? So output, I should get 10. Yeah, let me run the program. Yes, written spelling wrong. R-E. Semicolon, yeah. Fine. Let me run again. Yeah, you see the students here. I got expected output. What's expected output? That is 10, right? Uh, is 10, right? So let me clear my drawings. Yeah, let me clear my. Now the same statement, okay? Let me comment this. Now the same statement I'll write like this. Okay. A, that's what I said. A1, I can write it like this 10. I can write it like this 10. So in order to differentiate, let me put as 100. Okay, let me put as 100. In the output, I should get 100. Okay, the same above statement as I said, I can write in this form also. Okay, now let me run the program. You see the students? You see that I got the output called 100. So what it means, the same statement which you have written here can be written like this also. Both are valid. This is a valid statement. This is a valid statement. This is true only for a single argument constructor. If a constructor is taking single argument, that single argument constructor can be written like this also. Can be written like this also. Okay. So I proved it. Okay. Fine. That's good. So let me clear my drawings now. Now let us discuss about explicit constructor. That's what I said. Okay, in today's class, we are going to discuss about explicit. Okay, explicit. We are going to discuss about explicit constructor. Okay, we are going to discuss about explicit constructor. So what is this explicit constructor? Let us discuss now. Let me scroll up. Yeah. Now inside the class called A, as you see that inside the class called A, this is the class called A. So inside the class called A, I have a constructor. This is a constructor. This is a constructor. Now what it says, I need to make this constructor as explicit constructor. This constructor which is present inside the class called A, I need to make this constructor as explicit constructor. How I can do this? I can achieve this by prefixing with the keyword called explicit. Okay, I can prefix the keyword called explicit. So once I prefix with the keyword called explicit, then this constructor is going to become an explicit constructor. I repeat, the constructor which is present in class called A, you want to make it as explicit constructor. For this constructor, you need to prefix with the keyword called explicit. Okay, so then this constructor is going to become explicit constructor. Okay, if there's no keyword, if you're not prefixing any keyword, in other words, I've written a constructor something like this, then we call uh, sorry students, actually internet is not good today, it's coming up and down. Can you see my screen? Right, I hope you can see my screen. Students, I hope you can see my screen. My voice is audible, students? Can you please confirm? Yeah.
Yes, sir.
Fine, fine. Thank you. Yeah. So that's what I would like to say here. Now, this is a normal constructor. This is a normal constructor, right? But generally, actually, we'll never call this. We call this as implicit. You can consider this as implicit. We call this as implicit constructor. No one will call this as implicit. You can consider this constructor as implicit, but no one will use the word called implicit. Generally, they'll call as constructor. If they call constructor, it means that it is an implicit constructor. Okay, no one will call it as implicit constructor. Just they'll call constructor. If say constructor, it's nothing but it's an implicit constructor. Now, what I want now, I want to make this constructor as explicit constructor. I want to make this constructor as explicit. I want to make this constructor as explicit constructor. Now, how I can make this constructor as explicit constructor? In not to make it as explicit constructor, I need to prefix with a keyword called explicit. I need to prefix with a keyword called explicit. Right? So once you prefix with a keyword called explicit, then this constructor is going to become an explicit constructor. It is no more an implicit constructor. So let me clear my drawings and let me do this. And before that, you see the students, when I've executed this program, I got the output called 100, right? So for your sake, let me execute it again. Yeah, you see that? Let me clear my drawings and let me run this. Yeah, you see the students, I've executed. I got the expected output, that is 100. I got it, right? Now I'll do a small change. So in this implicit constructor or a constructor, I'm going to make it as explicit. You see that? You see that? The keyword explicit says that this constructor is a explicit constructor. Why? Because I prefixed with a keyword called explicit. Now it has become an explicit constructor, right? Now let me run this program. Whether we see we get expected output. See the students, I got an error. Previously I got the output. Let me get a marker. You see that previously I got the output. So once I make this constructor as an explicit constructor, I made it as an explicit. Once I made it explicit constructor, I'm getting an error. What error I'm getting? Let me change my marker color. Yeah, you see that I'm getting an error. What error I'm getting? Conversion from int to non-scalar type called A is requested. What it means, as you notice students here, 100. What's the type of 100? The type of 100 is int. Okay, and this integer value, what you're trying to do, you're trying to store in a variable called A1. And what's the type of A1? What's the type of A1? It is A. You see that? How we can place this integer type? I'm trying to place this integer type into a variable called A1, which is of type A. See, actually I can make it here a little bit clear. Suppose I written int A equal to 10.3. And what's the type of this 10.3? It is float. Is it right, students? It is float. Now this float value, what I'm trying to store in A. And what's the type of A? The type of A is int. Okay, this is one type and this is another type. Okay, so that's what here it says that integer type. So 100 is an integer type, and integer type you're trying to place in a variable called A1. And what's the type of A1? The type of A1 is a. So we call this as non-scalar type. So here A is a non-scalar type. Actually, they use some terminologies, non-scalar. What is scalar? Int, float, double, all with this we call this as a scalar type. What is the scalar type? Int, float, double, all these things you're going to call as a scalar type. What is non-scalar type? Anything which is defined by the user, that is class name. Here, what's the type of A1? It is A. So that's why we call this as a non-scalar type. That's not required terminologies. Only one thing you should understand here is this integer type. What I'm trying to do, I'm trying to store in A1, and what's the type of A1? The type of A1 is A, which is not possible. I can't store, right? It is basic thing. Is it right, students? Right? So that's why I'm getting the following error. How this error can be resolved? So in order to resolve this error, what I should do inside my program. So let me clear inside my program. Oh, let me clear. 1 second. Let me clear it. Let me erase it. Yeah. So in order to resolve this error, what I should do? In order to resolve this error, what I should do inside my code? This is the line. This is the line which is generating. You see that, students? Line number. It is telling. You see that? What is the line number? Show that line number 34. You see that's the line number 34. That's what it says. Line number 34. 12 is nothing but column. Okay. Line number 34 at column 12. This error is generating. Now, how I can resolve this error? In order to resolve this error, what I need to do? I need to do. Okay. In order to resolve this error, what I need to do? I need to do explicit typecasting. Okay. So let me clear my drawings. Let me put here. I need to explicit typecasting. I think you know about this typecasting, right? Now, what I'm telling here, this 100, what is the type? The type of this 100 is int. The type of 100 is int. Now, this int, what I'm doing, this int, I'm typecasting to A. In other words, I'm changing this integer type to non-scalar type called A. Now, since this 100 is a non-scalar type, that is A, now I can store this 100 in A1. Why? Because A1 is of type A. Okay, that's what it is. We should do. We call this as explicit typecasting. Okay, now let me clear my drawings, and now let me run the program. You see the students now. Now you got the desired output. You see that? Now I got the output. Now I got the output. How I got the output? Explicitly, I have converted. How? What I have done? Explicitly, I have converted an integer value into a non-scalar type, that is A. Now, let me come to conclusion. Okay. Let me put it. Actually, I'm removing so that I can put in a single frame. Okay. Now, what is this now? What is explicit constructor? When I say explicit constructor, when you write any statement something like this, then explicitly you need to typecast. Okay, that's the meaning of explicit constructor. Whenever you're using a constructor as explicit constructor, so when you're trying to use a statement something like this, then explicitly you need to typecast the value into corresponding non-scalar type. That's why we call this as an explicit constructor. If you don't write, as you notice, when you don't write this explicit constructor, this is an implicit constructor. Means implicitly my compiler is going to convert this 100, which is an integer, to a non-scalar type. Okay, that's what it is. I hope you understood this, right? Explicit means explicitly you need to typecast. If you remove this explicit keyword, I said we can consider this as an implicit constructor. Why implicit constructor? Means it's going to convert the value 100 implicitly into a non-scalar type, that is A. That's the meaning. I think I finished with my discussion. You understood this, students? That's the meaning of this. Okay, let me clear my drawings. That's only one thing. When you see the word called explicit, means explicitly you need to typecast. Explicitly you need to typecast. Why you need to typecast? Because 100 is an integer. Integer value I can't store in non-scalar type, that is A. So that's why explicitly you need to typecast. This is true if you include an explicit keyword, if you prefix an explicit keyword before your constructor, right? But the same thing, so now you see that now, let me remove this. Now, let me remove this. So let me remove this, and now let me run the program. It is, I can see that. It's throwing an error. Why it's throwing error? Because I think actually code and all I have removed it, right? I'm sorry for that. But anyhow, I think I have removed the code. Okay, fine. Let me clear my drawings. That's what it is, explicit. Okay. Now, if I remove this explicit keyword, if I remove this explicit keyword, then no need of this typecast. There's no need of this typecast. So why? Because because my C++ compiler implicitly it converts. Okay, implicitly it converts this integer type into corresponding non-scalar type, that is A. Okay, I hope you understood this. Any questions, students? Any questions you can ask? Any questions you can ask, students? Any questions, students? Any questions?
Sir, what is use of explicit constructor?
What is the use of explicit constructor? Actually, I'm not sure about it, what the use of this explicit constructor, but probably when you write the program, probably may arise a situation where you need to use this explicit constructors, right? But right now, it is one of the way where we can declare a constructor. I'm not sure about the use of this explicit constructor. Okay, you should know how to write this explicit constructor. That's all. The same thing can be achieved with respect to an implicit constructor. That is normal constructor. We can achieve it. Okay, what's the use? I'm not sure about it. But it's one of the way where you can declare a constructor. Okay, that's fine. Probably in MCQs you may find this question, so it may helpful. So how it is useful means probably in MCQs you may find this question. Probably at that time you can answer the question. Okay, fine. I'm not sure about this. Okay, fine. That's good. Any other questions, students? That's a good question. Any other questions from your end? Okay, no other questions. That's well and good. Now let us move to this copy constructor. Now let us move to this copy constructor. This copy constructor is very important, and you can try to focus this. Focus. Okay, it's quite simple. Also, there's nothing. Yes. Now let us move to copy constructor, and let me adjust the code. Copy constructor. I don't want this. I don't want this. I don't want this. Yeah. No. I think you know this code, right? Probably this code I've written several times. You can understand. Now I'm trying to discuss copy constructors. Okay, what is this copy constructor? What is the name itself says copy constructor. Copy constructor. Copy constructor. Okay. So when you're trying to copy one object to another object, then this copy constructor is invoked. I repeat, when you try to copy one object into another object, in such a case, this copy constructor is invoked. So let me do it. So here you see the students have created an object called A1. I've created an object called A1. Now what I'm going to do, now I'm going to create one more object. A2, sorry, A2 equal to A1. You see the students here, what I'm trying to do here. I'm trying to copy the contents of A1 to A2. I'm trying to copy the contents of A1 to A2. So when I'm trying to copy the contents of one object to another object, in such a case, this copy constructor is invoked. That's what copy constructor all about. That's what copy constructor all about. When you try to copy contents of one object to another object, in such a case, this copy constructor will be invoked. If, for example, when I execute this statement, what's going to happen? An object will be created, that is A1. And the contents of this object is A, and the value for this object is 10. Okay. In next statement, what I've done, I've created A2 equal to A1. So what is going to happen? And one more object is created, that is A2. Okay, A2. And inside A2 also I have a A. Okay. And what is the value of this A2? Sorry, what is the value of this A which is present in A2? It's nothing but the contents of this. That's what it says. What value I'm having here, the same value I'm trying to copy here. What's the value here? 10. The same 10 I'm trying to copy here. Okay. For example, let us assume I have one more variable called B, which is having 20. This is having 20. Then A2 also will have a B. Okay. Now, what's the value here? B, that is 20. And the same value I'll be copying here also. And what's the value? It is 20. That's what it is. Copy constructor. Okay. You're trying to copy the contents of one object to another object. So when you're trying to copy the contents of one object to another object, in such a case, this copy constructor is invoked. So how it is copied? So like this. Okay, like this. So 10 to 10, 20 to 20. So like this is going to copy. Now the question comes. So there are several cases where this copy constructor will be called. There are several cases this copy constructor will be called. So let us discuss each case one by one. Okay. Let us discuss each case one by one. So this is the first case. This is the first case. So this is the first case where the copy constructor is called when trying to assign one object to another object. This is first case. Okay. There's one more case where the copy constructor will be called. What is that? So let me write a small program for this. Let me write. Wait. Erase this. 1 second, students. Let me erase this. Yeah, erase this. Void, and this test belongs to is called A, right? And now I'm calling A1 dot test of 2. That now what I'm doing, students, here you see that A2, what is that? It's an object. A2 is an object. You see that I've created an object called A2. In this A2 object, what I'm trying to do, I'm trying to pass to OB. And what's the type of OB? It is A. In other words, it is something like this: AOB equal to A2, equal to A2. You see that what is A2? A2 is an object of type A. Here what I'm trying to copy A2 to OB. So in such a case also a copy constructor is invoked. In such a case also a copy constructor is invoked. Is it right, students? Next, let us go to next case. Next case. Let me remove this. Next case. Next case. And let me create a temporary object. Right, students. Let me pull it up. You know, here what I'm trying to call a method called test. I'm trying to call a method called test. And what this method test is trying to do, this method test is trying to return a temporary object. And what's the type of this object? It is A. So that's why here I should make it A. And above also I should make it A. Okay. Now this test method is trying to return an object called temp. And this temporary object I need to store in one more variable, right? So that is A3 equal to B. Why you written? What's the type of A3? The type of A3 is A. Why it is A? Because temp. What's the type of this temp? The type of temp is A. Okay, it's trying to return a temporary object. This temporary object, what I'm trying to do? I'm trying to store in a variable called A3, and the type of A3 is A. It is something, it looks something like this. Okay, you can think something like that is A3, A3 equal to temp. Okay, you see that, and I'm copying this object to A3. Okay, so this is my first case. This is my first case where a copy constructor is invoked. And what's my second case? So this is my second case where my copy constructor is invoked. And what is my third case? Altogether. Altogether, this is my third case where a copy constructor is invoked. These are the three cases where a copy constructor is invoked. Is it right, students? Yeah. Now I'm telling copy constructor and copy constructor. Where actually this copy constructor is present. Now, this copy constructor will be present. This copy constructor will be present inside the class called A. This copy constructor will be present inside the class called A. Can you find a copy constructor inside the class called A? No. You see the students inside the class called A, I have only one constructor. I have only one constructor. But this constructor is not a copy constructor. I have only one constructor called A, but I don't have any copy constructor. See, when you don't have any copy constructor inside the class called A, by default, your C++ compiler is going to provide a default copy constructor. I repeat, inside the class called A, I don't have a copy constructor. If I don't have a copy constructor inside the class called A, by default, your C++ compiler is going to provide a default copy constructor. Now the question comes, how this default copy constructor look like, right? So let me write here. So this is how a default copy constructor looks like. So since the name of the class is A, so my copy constructor also will have the same name as a class name. Okay, same name as a class name. So as you know that this is how a default constructor looks like. But right now I'm discussing with respect to copy constructor. So for copy constructor also we'll have the same name as a class name, but inside this is going to take an extra argument of type class name followed by ampersand and followed by the name of, it can be any name. So let me take it as obj, obj, and inside this I'll write star this equal to a obj, a obj. So this is how your default copy constructors look like. Okay, so this is how your default copy constructor looks like. Okay, if you don't write any copy constructor inside your class, okay, by default your C++ compiler is going to provide a default copy constructor. Now you may ask questions of what is this, all this stuff. Anyhow, let me explain this. So as I said, so when I write a statement something like this, a2 a2 equal to a1. Okay, when I'm trying to copy the contents of object a1 to a2, what's going to happen? This default copy constructor is invoked. So the most important thing here to observe is here I'm calling copy constructor with respect to a2. Why I'm calling copy constructor with respect to a2? Because I'm copying the contents of a1 to a2. Okay, now so when you write a statement like this, what's going to happen? This a1 will be passed to this a1 will pass to a obj. So this a obj is nothing but it is your a1. The contents of a1, what I should do? I should pass to a2. Okay. So what is this? This is a keyword which always refers to the current object. Okay. So now, as I said, I'm calling this copy constructor with respect to a2. So this is a keyword which is referring to this a2. So now this is nothing but it is a2. A2 is nothing but your this. Why? Because I'm calling this copy constructor with respect to a2. And to be more clear, when you try to compile the code, this code will be converted something like this. And don't try to get confused. You'll call like this: a2 dot a of a1. Okay, actually, still it gets converted. I don't like to discuss in deep this. Okay. Now, what is a2? See, you see that I'm calling copy constructor a with respect to a2. Since I'm calling copy constructor a with respect to a2. This keyword refers to a2. Okay. Now, what I'm passing here? A1 I'm passing. So this a1 I'm passing to where? A obj. So then this name can be any name. Say general I pick A obj. It can be any name of your choice. It can be X, Y, Z. It can be any name. Okay. But why you written A obj? It stands for object of a class called A. Okay, that's why I picked the name as A obj. But this name can be any name of your choice. So this is how your default copy constructor look like. I hope you understood this. Okay, this is how your default copy constructor look like. Okay. Next. And next question. Now, as you see here, students, as you see here, is very important observation. Okay, the difference between a normal constructor and a copy constructor. For a copy constructor, you see that I put ampersand here. Why I put ampersand is very, very important. See what I said, I'm copying A1, right? That's what I said. I'm copying A1 to A obj. If I don't write ampersand, what's going to happen? It looks something like this. That is A obj equal to A1. You see that? What I'm trying, as I said, what I said, students, in case to what I said, if I'm trying to pass A1 to A obj, again a copy constructor is called. In other words, the constructor will be called recursively. So we can't stop this. So that's why inside the copy constructor, they prefix this ampersand. They prefix with ampersand. When you prefix with ampersand, then copy constructor will not be called. Okay. So that's why ampersand is present inside this. Okay. That's the main intention of including this ampersand. So what's the difference between a default constructor and a default constructor of a copy constructor? There's only one difference. What's the one difference? Here I'm trying to pass an argument. Let me change the color. You see that what's the difference? You see that I'm passing this extra argument. And not only that, inside this, you should include the corresponding statement. That is star this. This is a statement, you need to include this. Whereas a default constructor, it looks something like this. Default constructor, it looks something like this. This is a default constructor. Okay. Now, if copy constructor, how it looks like? A, and inside this argument of type A. Why A? Because my constructor is A ampersand followed by any variable name. I picked the variable name as A obj. Then you open the flower brace, close the flower brace, and inside this we should have this pointer. This pointer always points to the current object. So this equal to A obj. Okay. So this A1 is nothing but obj, and this A2 is nothing but your this. That's all. I can have the difference between these two. Now let me remove this. You can see the difference. Okay. This is copy constructor. So this is your. So this is copy constructor. This is copy default. This is default copy constructor. Default copy constructor. This is normal constructor. This is normal constructor. Both are default. This is default constructor. Is fine, students. Anyhow, let me type it. Let me clear all my drawings and let me write how a default constructor looks like. So let me type the code. A. Okay. A. And inside this, I'll be having A ampersand A obj. Okay. Inside this, writing star is equal to A obj. So this is how your default copy constructor looks like. It's very, very important. Okay. This is how it looks like. So when it's going to call, so this default copy constructor will be present inside the class called A. When it will present, if we don't write default copy constructor, sorry, if we don't write our own copy constructor, if you're not writing your own copy constructor, then C++ compiler is going to provide the corresponding default copy constructor. How it gets invoked? So whenever you create an object, something like this, that is A2 equal to A1. Okay. When I'm trying to copy A1 to A2, then with respect to A2, this default copy constructor is invoked. So now what is this A obj? Obj is nothing but your A1, and what is this? This is nothing but your A2. Okay. A2. This always refers to current object. I'm invoking copy constructor with respect to A2, and that's what. It's quite simple. Any questions, students? Any questions? Okay, students, in case the session gets terminated, you can use the same link to rejoin again. Okay, in case the session gets terminated, you can use the same link to rejoin again. Is it fine, students? Yeah, that's good. And let me clear my drawings and let me prove how this copy constructor is going to invoke. Okay, now let me write my own copy constructor. So now let us discuss how to write your own copy constructor, right? So what I'll be doing, and inside this class called A. Now let me write. I have written this, and it is not required. Now let me write this own copy. How to write a copy constructor? A is a standard style. A ampersand. It can be any variable. Okay, A obj. Okay.